in this part, we're gonna start looking at more how to calculate some probabilities and percents using what's called the normal model. And the first way to do this, and it is a very basic way, and it's kind of just a way to estimate these things, is called the 68, 95, 99.7 rule. And what this says, so we'll talk about this curve in a minute. But when you have, so this is a unimodal symmetric distribution or histogram. And so if you have that, this isn't necessarily true with skewed or bimodal. But when you have this unimodal symmetric histogram, 68% of the data will fall within 1 standard deviation of the mean, 95% fall within 2, 99.7% fall within 3. And so if you remember from the first video, if we're talking, we're measuring distance from the mean. So we should remember, hopefully you remember, we're talking about the z-score. So if we say that 68% are within 1 standard deviation of the mean, that means that z is between -1 and 1. If we say 95% fall within 2, that means that z is between -2 and 2. And then if we say within 3 standard deviations, then z is between -3 and 3. And so this kind of also gives us an idea. I kind of hinted at this and said we were talking about this in the first video. What's a big z-score? Like what would be considered far from the mean? You can see that almost everything is within 3 standard deviations of the mean. And so what that tells us is that between -1 and 1 is very common. As you get out to 2 and 3 standard deviations away from the mean, or a z-score of 2 or 3, then you're getting pretty unusual. And if you get beyond 3, then you know it's questionable whether that's even a valid data point. Obviously it could be, but those are such rare occasions that if you ever see that, you might want to, like if you're ever doing a problem here and you get a z of 4, you might want to check to make sure that you didn't do something wrong. So keep that in mind. And then we're going to be using this rule to solve some problems here in just a minute. But first, let's talk about the normal model. So the normal model is just like that histogram we were just looking at. So a histogram that looks like that. So this is, a lot of times this is called the bell curve or the bell-shaped curve. It's bell-shaped, unimodal, symmetric. And so that's important for all these problems that we're going to be looking at. So we have, and let's say, I guess fairly obvious, the mean is in the center. So the mean will be right in the center of this histogram. We don't really talk about the median when we're doing these, but the median and the mean will be about the same anyway if we're talking about a symmetric distribution. So we're going to let mu, which we saw in the first video, mu is the population mean. And then sigma is the population standard deviation. And then if we write this notation, capital N mu comma sigma, this implies a normal model with a mean equal to mu and standard deviation equal to sigma. And obviously, you don't really put mu and sigma, but whatever those numbers are. So you'll see capital N, and then it looks like an ordered pair with 2 numbers. The first number is the mean, the second number is the standard deviation. So that's just kind of a shorthand way to keep from writing all of this. You can just use this as a shorthand. So when you see that, that's what we're doing. All right, parameters and statistics. So we'll talk about this more in a couple of chapters, but let's just kind of introduce this here. So parameters are numbers that help specify a model or help describe a model. And this would be your mu and your sigma. So you notice I didn't just say mu is the mean and sigma is the standard deviation. We have to specify it's the population mean and the population standard deviation. That's as opposed to a sample mean or a sample standard deviation. And so when we talk about samples, we're actually talking about statistics. And statistics summarize data. And when we talk about data, most of the time we're talking about samples. And so these would be like X bar. X bar is the sample mean. And so that's as opposed to mu, which is the population mean. So those are different things. They're probably close in value, but they are different. And especially when you're just speaking generally, they are different. And then we have S. S is so sigma is the population standard deviation. S is the sample standard deviation. And then we talk about the median of a sample. We can talk about the mode, all those things. So these numbers summarize data, whereas population numbers kind of talk about a model for data for a population. And all right, so referring back to this would be a normal model with a mean of 0 and a standard deviation of 1. And this is called the standard normal model. All right, and then last part, normal model should only be used if the data is symmetric and unimodal. If it's skewed or it's bimodal, multimodal, then you probably should not use the normal model. All right, so let's look at an example. So each part of the SAT has a mean of 500, standard deviation of 100. Assuming the data is symmetric and unimodal, or assume that, if you earned 700 on one part of the SAT, where do you stand among all others? So what percentile are you in? Let's ask that. So we'll just kind of write that instead. What percentile are you in? And if you remember from chapter 2, percentile, if you're in the 80th percentile, then you did better than 80% of the population. So how'd you do? Now, first thing you should always do when you're doing these problems with a normal distribution is draw a picture. So we're going to draw the normal curve, and we're going to label it appropriately. So what goes right in the middle? So the mean always goes in the middle. It's always the first thing you do. And we're going to use the 68, 95, 99.7 rule. So we're going to add and subtract the standard deviation. So if you add the standard deviation, you get 600. You subtract it, you get 400. Now, according to that rule, we know that 68% of the scores will be between those two. All right, we are interested in 700. So let's do it again. Add 100, we get to 700, we get to 300. And what do we know about that? That's 2 standard deviations above the mean and 2 standard deviations below the mean. So that would be 95%. And if we wanted to do it again, which we don't need to because we're interested in the 700, but if we wanted to do it again, we could get to 800 over here, we get to 200 over here, and then that would be 99.7% between 200 and 800. But we want to know what percent are between, or sorry, what percent is below 700. And that would tell us the percentile. So we know that 95% will be between 300 and 700. Now, what percent would be less than 300? Because we need to consider all of this all the way down, even that part. So 95% is between 300 and 700. What would be left? So we have 5% left over in the tails. Now, this is where the symmetry comes in. If you have 95% in the middle, that leaves 5% in the tails, and we'll have half of the 5% over here. We'll have half the 5% over here, which is 2.5%. So what percentile? We have 95% plus 2.5%, which is 97.5. So you're in the 97.5 percentile if you score 700. Okay. Now you could also do like what percent score between 600 and 700? So how about, what would that be? Well, we know that 2.5% is over here. What percent would score above 600? So we have 68 between 400 and 600. So that would leave, let's see, 100 minus 68. That leaves 32% in the tails. Half of that 32% will be over here. Half of that 32% will be over here. So 16% would be above 600. 2.5% would be above 700. So that leaves the difference of 13.5% between 600 and 700. So you can use this symmetry to get any of these sections. So we can't use this rule for anything. Like if we wanted to find what percent scored below 550, you could not use this rule. We'll learn how to do that. But this rule only works if you're talking about scores that are either 1, 2, or 3 standard deviations above or below the mean. And then you could get any combination of that. So we could get between 300 and 500. We could get between 400 and 700, 400, 600, 405, whatever it is. You can get any of these combinations using the symmetry. And if you understand this one, you could probably do any of them. So yeah. So if you have any questions, definitely send me an email and we'll look more into that. All right, so we'll stop this one here and we'll pick it up on the next one.